Hello and welcome to our second video on intersection of solids. Just to briefly look back on our video 1, the topic intersection of solids would also previously have been known as interpenetration. Some of the key words and key terms we came across: a point where a line touches a surface is called an intersection point or a pierce point, and a point on an edge where a surface or face changes direction and the line of intersection changes direction is called the turning point or bend point. And in the previous video, the method that we used was called the limits method. The limits method works really well for basic shapes, basic prisms, but when we get into anything more difficult than that and we start introducing maybe pyramids like we have in this case here, the limits method won't work for us. We have to use the elements method. So the elements method is just one of our methods that we can use for this. There are some more that will be coming up in the upcoming videos, but for now we're going to use an elements method to solve this intersection of solids question that's presented here in front of us. As you can see there is a green square based pyramid, and then there is the yellow square based prism intersecting, and that is our task right now is to find the profile of intersection as these two objects, as the yellow object wraps in around the two surfaces on the green object. So that's what we're going to be going ahead and doing now. Just to get started here on paper, I'm going to just project. So I have my elevation and plan given. I'm going to project my end elevation just to get as much as I can on paper. Now, I know there from looking at my SolidWorks view that the object is, as it appears here in the end elevation, I get my two straight outer edges, but that this main edge going through to the front is obstructed by the square based prism. So I can just, at the moment, draw the two outer edges of the pyramid over here. But I can't make the main line going down through here solid yet, because I'm not quite sure how much of it is solid. I'm going to add some labels to this now as well. I'm going to have 0 up top. I'll go A, B, C and D as the edges on this pyramid. So 0 up top, A on the left, B and D, or sorry, I should say D is the one nearest here. D come out B because we're viewing in this direction to see this end elevation, and finally C is here on the right. And in the main elevation I have B, I have A and C, and I have point D. Next I'm going to just project the prism. And I see the prism here as its base shape, or just as a square in this view. So I can heavy that in. There we go. Once that square is in, I know that it's a prism, so it's all standing directly, it's extruded away from me on the page. I can heavy in the edge from 0 down to D, just to the top and underneath the prism, just like so. Down here in plan, I also know for sure that the the object doesn't push all the way through, and the back half of this is, again, it's completely untouched, so I can just heavy in a portion of that right up to halfway here. And it's going to be the same thing here up in the elevation. The left half is just untouched because this prism only intersects onto one side of the object. I'm going to take a few moments now to add some colour before I start explaining the method and working through it. We'll add a little bit of colour onto the object again just to help the understanding. Now, that much is done. Just added a bit of colour that I could add, and I need to just label around my prism. So I'm just going to label this 0.1 up top, 0.2 here at the back, 0.3 and 0.4. They are going to be my 4 main edges of this prism. What do I have in the elevation? Well, I have 1 and 2, so 1, 2, and what do I have down in the bottom one? It is 4, 3. And down in planned in, it's 1 and 4 will be out here at the front, 1 and 4, and then 2 and 3 here along the back, 2 and 3. Now, here's the challenge, and here's the difference this time. In previous examples where we had the object standing up off the ground, a prism, I had a 0.2 in the end view projected across, and I saw where 0.2 came in and just hit. It penetrated the object at a specific point, and if this was a square-based prism, it would be hitting right there. But this time it's different. It goes in along the object and stops someplace in here, and we don't know where. So that's where the challenge is here. That's why the limits method won't work. So for any form of pyramids or cones, limits method is not going to work for us. We need to find the exact point where, let's just say, for argument's sake, edge 2 goes right in along. It obviously goes past this base point here because it's way higher up on the pyramid, and it goes right in, and I'm assuming that it hits it pretty close here to the edge C. If we can see, there's the edge C. That's quite close to it. So if it's that close to it, it must be hitting it pretty close around here someplace. So there's our challenge. We just have a quick look on SolidWorks. An element is a straight line in the surface. So how can a straight line in the surface help us here? Well, a straight line can be a fixed line that we can find in every view, such as that red one I just dropped in right now. If we see what that looks like on our page, that red line goes from the apex of the pyramid down through the pierce point or the intersection point and right down onto the ground. So let's see what that looks like on paper. We're going to take a fixed line or an element from 0. I'll start off with 0.1 right there, and I'll go down through 1 onto the ground. So that's my first element, and I'm just going to call that element number 1. It goes from 0 down to 1. Now it's red 1, it's going through the black point 1, but I'll just go with the same number, red 1 right there. The red point 1 is on the base profile, so I better find that down in plan now next. So the red point 1 is what I'm looking for, and it's on the ground. And which half is it? Is it on the left side or the right side? Well, it must be on the right. This object only penetrates on the right hand side, so that right there is red 1. So it's time to draw that generator in a second view. So I have my element. I've drawn my element in one view. An element is a straight line that lays on a surface. It lays from point 0 down to point 1, and it crosses through the intersection point 1 along its way. So from 0 down to 1, and along the way it got me the intersection point number 1, which means if I take edge 1, project it in, I get intersection point number 1. There's intersection point number 1. If I have it in plan, if I have it in my end elevation, I can find it in my elevation. So 1 is already projected across. Now it's time to just project it up from plan. There's point 1. So there's a good start for us. There's 1. So first one done. Let's have a look at what's next. What should I be doing next? I should probably go from 1 and go down here maybe to number 4 down at the bottom. Keep on this same face here that goes 0 from A to 0 to A to D. So 0, A and D, because point 4 also goes in and hits that triangular face. Let's have a look on the SolidWorks model. And there we have our element going from the top. It lays on the green surface, it touches point 4 down below, and it goes onto the ground. So let's draw that one. Point the element at 4 touches the ground at number 4 right there, and we project that point down to plan. When we project this across, again we need to find ourselves on the ground profile. This edge here that lays on the ground gives me point 4. I'll draw the element 0, 4. And on the element 0, 4, I get intersection point 4. Now, just happens that that intersection point seems to be all along the same line as 1. That is perfectly correct. It's all down along the same surface. So that is fine. We're okay with that much. I can find point 4 up in the elevation. And I've labelled 4 down here, so I'll just project 4 up onto it. When I'm in this position, looking in, seeing the object, well, I can see the full face of the object here from 1 across and through to 4. If we look at this model, if we look at the elevation, we're seeing the full face of the object just like that, which means we can join the intersection point 1 down to the intersection point 4 as a solid line, because it's right there in front of us, it's visible and we can see it. There we go. Now, I did not need to do what we can see here on the model. I did not need to draw the red elements in the elevation and the plan, because as long as I have them in the plan, that solves the question for me. It gives me my 2 points. As we can see here, point 1 and then point 4 is just here underneath. There's a lot more detail here in plan though. As you can see, we have it coming from point, what's that, 1 over to a bend point and on up here to point number 4. So let's go for that one next. We'll figure out the bend points next. There's still some more detail of course needed down here, but right now I'd like to go and find the top bend point and find number 2. So I'm going to go from 1 to BP1 to 2. Where is BP1? Well, it is right here in the in view. Again, we're back to the view that shows the perimeter of the object here, and that right there is BP1, bend point 1. It's on the edge 0B. It's going to be on this edge right here, or 0D I should say, sorry. And I'll take it across to the elevation and I have BP1. So right there is BP1. I'll take it from the elevation down to the plan. Again, it's on the edge 0D. And right there we get BP1. As I look down the plan, I can see that 1 joins to BP1. And there we have that. Working across from 1 to BP1 and on to 2 next. I'll draw my element through 2. I project red point 2 down to plan. That's red 2. And I'll draw the element and plan. That gives me the intersection point of the edge here at 2. That joins back to BP1. And there in plan, I can now heavy in the area from BP1 up to 0, up to the apex. So that's after clearing up that plan quite a bit for me. Anything to add in the elevations, the next thing? Well, what we'll find is that the intersection point 2 there, it's lining up perfectly with the intersection point 1. So 1 is there, and if I go comma, 2 is also right there. So I have gone from 4 up to 1 to BP1 to 2. Where does it go from there? It must go down to number 3. So I've gone 4, 1, BP1, 2, 3 is next for me. So another element takes me down to 3 on the ground. So these elements are merely a straight line on the surface, which if I can find a line in a view, I can find a point on that line in a view. And there we have point 3 on the ground. And that gives me element 3. And that straight line element gives me point, so 3 goes in and hits point 3 is right there. Oh, maybe due to a slight inaccuracy there, 3 and 4 aren't perfectly lining up. They probably should be, I suppose. But where do we go next? So I've gone around the object from 4 up, across, down to 2, down to 3. I need this next pin point right here, BP2. Pin point 2 is on the edge from 0 down to D. Where is it? If we just look here in the model, you can see that as you see under the object, we go from 2 down to 3. It goes across the bend point and back to 4. That's what we're going to be looking for next, is this bend point right here. It's still on OD. So on the edge OD, we have bend point 2 projected across to give me BP2 right here. Projected down to plan. BP2. Now, have I joined everything up? Have I drawn everything I can? So up in the elevation, I know that I can heavy in the object down to the bend point and from the second bend point down, but that's all I can show in the elevation. There's nothing else to actually show there at all. Unless, again, I assume that I can put a hidden detail line here, which is what I was going to close in the last video with. And SolidWorks, because of the way I drew these, will show a hidden detail line going through. In other words, the prism hasn't cut through the object, it is just formed around the object, and the edge of the object still exists. So again, that's all situation specific. Down in plan though, I'm missing a bit of detail now at the moment. I'm missing the detail that this surface makes. Okay, that surface right there, the contour that makes as it wraps around. So it goes from point 3 here at the back, out to the bend point, and out to point 4. And as I look down on top of the object, it's going to be hidden detail because it's underneath. So 3 out to the bend point, and the bend point out to 4. If I just add a little bit more colour here now, it might help to visualize this. And there's the finish. intersection. Now if we just have a quick look at the SolidWorks model here and just make sure that everything is as it should be when we turn our hidden detail on, well, again, SolidWorks, due to the way I model this, is showing the hidden detail line going straight through. That's the elevation shown. The end elevation, which was the first view that I drew, well, we have everything there. Again, it shows the hidden detail line going through. It's not really a big deal, it's a questionable one. And the big view here is down in plan. Did we get all the detail there? Well, the only thing I should actually add in just now is maybe just, didn't really look like a need there for me, but I think it does now, just a heavy in the base edge. And of course the base edge is going to be hidden there. The base edge is going to be hidden or solid from C until we hit the yellow prism, and then hidden out as far as D, and a little bit of hidden up to bend point 2. And if you like, you can do hidden detail between the bend points as well. So there we go, the use of 4 element lines. So I'm going to just label those as element lines. So we have the use of 4 element lines this time to find our points of intersection, and we have our bend points the same as before. That is the first question completely finished. We're going to move on now to some different and more challenging ones. That sets us up. That's the method, and that's what we're going to be doing quite a bit of for this video. So on to our next one. Here in our second example, we have a pyramid, and this time there is no second object to intersect, but it's still the same principle that's going to be in play here. The hole that has been cut out is in the form of a square, and it is, let's just say, being extrude cut up through the piece, but in theory it's the very same as if there was a square based prism standing up through the piece. We'd still have to find all of our intersection points all around and find our bend points where the profile or the contours change. The model prepared here is really going to be helpful, I think, in visualizing what we're looking at. And sometimes it's kind of hard to see with these really complex looking profiles from the top. When we're looking down at a 3D view and it looks so complex, it can be hard to see how simple it all started off with this just square based cut that comes up through the object. We're looking down here on the plan first of all, quite similar to what we have here on paper. What I'd like to start off by doing is just, again, it's always good to help with the understanding. I'm going to heavy in the edges as far as I can. Now I'm going to go and just project up to the elevation, and I'm going to assume that this is a complete pyramid for now, and I'll just drop in the edges nice and light. I'll just label it first. So there's point 0, the apex, and I'll go with A, B, C, D and E. 5 points on the base. So let's just draw this up. Drop in my edges, keep them all light for now. And there's all the base edges, or all the edges of the pyramid, down to A, to B, to E, C and D. Now what do we do next? Well, we need to just start now by finding all of the points. So we need intersection points and we need bend points. I'm going to begin by what I usually begin with here. I'm going to add some colour here in the plan. Now let's get drawing. So we're going to just start off with labeling the top points here. So I'm going to have point 1 on the side of my square cut. I'll go for point 2, point 3 here at the back, point 4 here at the side. The easiest point I think on the whole drawing sheet has to be point 1 because it lies on the edge from 0 down to E. So I'm going to start off with that. So on 0 E I get point 1. I'll turn this guy back to 3D here so that we're having a look at the end goal all the time. And point 1, let's just go back to plan for a second. Point 1 is this one right here, which lies on the edge. So as we look up at the object, we'll follow point 1 up along. It just lies on the edge again. So back to 3D for now, and point 1 is the one we're going for. So point 1 on the edge 3. And there's point 1. Where does it go from there? So if I just work my way around, it goes here to bend point 1. So that is BP1. BP1, bend point 1 is on OA. And that is the most, that is the front face. So as I'm viewing up here at the object, I can see probably everything I'm sure that happens on this face and on this face, and I'm not quite sure can I see anything behind that. I'll have to try and make sense of that after, but for now, from 1 up to BP1 is definitely going to be solid. So joining from point 1 to BP1. What I can also do now is I can fill in the remaining edge of the object from 1 down to E and from BP1 down to A. And I'm going to add some colour. Next, I'm going to keep making my way around. So 1, BP1 onto point 2. And where is point 2? Well, I have no idea. So I can project point 2, but I don't know where to stop. It doesn't lie on any edge, so I need to use my radial line. So a radial line, or an element that goes from 0 through 2 onto the ground at point number 2 right there. Red number 2. Take that up and draw that same radial, or that same element line in the elevation. And that should get me, if I project from a point on a line, so if I can find a line in one view and a second view, I can easily project any point on that line between my views. And I get intersection point 2 right there. Now that is gone behind the object, so I can see my solid edge and I can see my blue face, and then it's gone in behind that. So that must be, I've gone from 1 up to BP1 down to 2, BP1 down to 2 must be hidden because it's gone in behind that blue face right there. This is why I think the colour is so important. 2 goes across 2. I'm going to call that bend point. It's another bend point right there. And what have I already used? I've BP1 used, so that's BP2. Bend point 2. Where is bend point 2? It's on the edge OB. OB, it's very hard to see it there since I added the colour. That's the edge OB. The bend point number 2 is on OB. It's right up there, so it's up above this. It's kind of a more interesting one. I need to join them up. I'll label that first, BP2. Time to join them up now. So from 2 up to BP2, well, again, it's hidden behind the blue surface here. But then it must be solid because it's sticking up through above the blue surface. Bend point 2 goes down to intersection point 3. And find my intersection point using an element. And that intersection point lies on the element here. So that is point number 3. Now this time I don't know if I can assume anything here. All the way down to 3, I'm quite sure some of it's going to be hidden and some of it might be solid. I don't know. I'm going to leave it light for now. So from bend point 2 all the way down there to 3, I'll leave it light for now. and 3. So I'm just keeping going around the perimeter. I need to get to this guy, which is a big bin point again. So that is BP3. Bin point 3 lies on the line down to C. Where's C now? C is the second one in. So bin point 3 lies on the line right there. Let's keep my colour scheme going. That's BP3. Once again, no idea. Is this hidden or is it solid? So I'll keep it light. How far have I gone around this thing now? You just keep going around the perimeter. BP3. 4 is next. Another element. Point 4 on the red line 4. So there's intersection point 4. What am I joining this time? And it's so easy to make a mistake, and the only pity is in the exam you can't do what I'm doing, talking to yourself through it. From bin point 3 joins down to 4. So bin point 3 joins down there to number 4, and again, no idea what's hidden and what's not. Bin point 3 down to 4. And from 4, we're going back up to, what will that be? BP4. BP4 is on the edge D. D is the extreme edge here at the right. And we're going back up again. That is BP4. Don't make the mistake now. This stage we've gone down to 4 and back up to BP4. 4 up to BP4 there. And what's left? We've gone all the way around BP4 to 1. Now that has to be solid because I can see that edge right there is right in front of me. So I know that one has to be solid. From BP4 back home there to 1 must be solid. Now if that's solid and BP4 can be seen, I know that that's the rest of the edge D all the way down to ground. I can grab my colour and add a splash of colour to this. And then it becomes much more apparent what needs to be heavy and what needs to be hidden, because this little peak right here has to be heavy because it sticks up above, and then this one down here needs to be hidden, I'm sure. Same story up here. Heavy down as far as it, and then hidden down below because it's covered by that front blue surface. Now I just need to be really careful now. I've gone around 1 BP1, 2 BP2, so 1 BP1, 2 BP2, 3 BP3, so 2, 3, bin point 3. From bin point 3 down to 4, bin point 3 goes down to point 4, so solid and hidden. And bin point, so 4 up to BP4. 4 to BP4, almost impossible to see it here. It's so close to the edge, but that's also going to be hidden behind this front blue surface. I'm going to add just a really light colour to the inside. I might just add a grey there, same as I have in my model, to those inside surfaces. And is that what we're seeing? Something similar to what we're seeing here in the elevation as we look in. Certainly is. Now, dimensions I used here for this model might not be 100% the same, but as we can see, we're getting that effect. The other big thing is when I turn on my hidden detail, what am I missing? Am I missing something? Yes, I am. What about the edges and what about the rest of the hidden detail? There's a lot more hidden detail shown right here. Let's look at that next. So every one of my edges of the main pyramid are still remaining in some form. Have I shown them all? Well, I've shown the one down to A, down to E, and down to D. So A is done, E is done, and D is done. Is the one down to C shown? So from bin point 3 down to C, it is not shown. So where is that? That's point C, that's bin point 3. So that's a full hidden edge all the way down there to ground, because that's at the back of the object, but we still need to represent it. that's C done. Have I shown the edge of the pyramid from 0 down to B? No. It goes from bin point 2 down to B, BP2 down to B. Unfortunately, we're not yet out of the woods. What else have we? Well, we have these vertical lines as well. And what them vertical lines represent is, if I just turn my detail back on and go back to a 3D view, let's just say this point right here, if I just zoom or rotate this a little bit, where the edges 1, 2, 3 and 4 cut straight down to ground will give us a vertical cut. So where 1, 2 and 3 and 4 happen to fall, it's going to be the same if I turn it this way. We have a vertical cut down to ground. If I bring it around to this side, we get our vertical cut, and the final one there, which is the first point I started with our vertical cut. So let's go and get those ones drawn. We should end up with an elevation much like this. So where my 4 points, 2 comes down to ground, 1, 3 here at the back, and 4 here at the side. And there we go. That is this one completely finished. Quite a bit of visualization involved. Interesting, nice little question to work on now, or something like this. And the great thing about these is, if you want to do this at home, draw your pentagon and just make up any square at all to fit that intersects down through it. And it doesn't have to be a square. It can be a triangular shape, it can be another pentagon, it can be anything you want, and get your practice in. So that is the second question for this video. We're going to move on now to something a little bit harder again, of course, but hopefully the use of these elements now and the straight line elements that I needed to find all of the 3 intersecting points, for point 2, 3 and 4. I didn't need to find an element for 1 because it's already lying on an edge. And then we have our 1, 2, 3, 4 bend points. So a good bit of practice going on in this case. And the important thing here is the story and the structure. How do we do it? How do we follow it around? Now, some people really like to do something like this. They want to be able to work between their views. Maybe if we had to put in an end elevation here as well, we might need this. Some people like to do this, and they say, I'm starting at point 1 here at the front, and I'm going to BP1. And then I'm going from there to 2, and I'm going from there to BP2. So some people really like to do this and have a structure or a story here. From 3 to BP3, to 4, to BP4, to 1. And that's the structure that they'll follow when maybe they have to project all of this now to an end elevation, or maybe it's just a harder drawings. You might need something like that so that you don't miss a step. Anyway, that's our second one done. We're starting to get a bit of practice now. The limits method was certainly easier last time, but there's a nice challenge in this and some good visualization. On to our next drawing. And here we are in our final drawing for this tutorial. So we're going to be looking at one of the more difficult applications of the elements method here, where what we have here is our cone and a cylinder extruded into to intersect. So it's going to be an interesting one. As we can see on the model, it's creating a full freehand contour all the way around the object. And it goes all the way around the left side of the object here as well. And if I just look in underneath a little bit, you'll see that it just wraps all the way around the base of the object too, much like it does here on paper. Now again, these models are just created to mimic the question. They're not an exact dimension of the question, so we get a good idea. But I think in the question sheet, this cylinder is going to be coming out a little bit further possibly, which doesn't actually change the extrude at all. So an interesting style question coming here. I'm going to get started by just drawing what I can draw of the end elevation, which is the part of the question, I suppose, that's really going to be the more or less the most difficult part. We get started by just projecting. I link my plan and elevation. Just make sure everything is accurately set up here, and I'm going to just take the base points of the cone, front and back, apex. And I know that the back of this object is not touched. Again, it's just going to intersect here around the front. The back is not touched, so that means that this generator on the cone is completely untouched. The front one is going to be affected by the object, so we'll just leave that one in light. What else can I do? I can project the top and bottom of the cylinder across, and how far out does it come? Well, we have it here in plan, so we'll just do them projections as well. Take the center of it here as well, I'm sure I'll need it. And the front of the cylinder onto my wide line. And there we are. So that's as much as I can do for now before I start thinking about my elements method. Is there anything else that's possible here? Well, at the moment, I'm at a little bit of a loose end. There's probably 2 points that I can take right now that might help, but where are they? So if we can think back to the last question, where we had an edge of an object coming down to the ground, we could see where it got hit, and they were, let's just say, bend points. Although on this question there are no bend points as such, because it is a fully wrapped profile. Having said that, when we look in at the elevation here, okay, as we look in at the elevation, well, if we get our elevation broken up into our 12 sections like we usually would, well, if we take that top point where it's touching the extreme front generator and the bottom point will give us 2 points on the profile of intersection. So the top and bottom point are coming out and touching the extreme generator. Okay, so that's just the first thing I can do, which makes it a little bit easier for me, just so I kind of get started here. So this top point right here and this bottom point right here, and I won't number them yet, I'll number them in just a while. Well, they're on that front profile right there, and that also means I can bring them down to plan onto the front generator. And I'll do all my numbering after. I just want to start with something. If the more we can get on paper, the easier it becomes to understand these type of questions. So we have one on the front generator here, the extreme, and where is that? Well, that's the one out the front here. So there's a point on the profile. And this time I don't like calling it a line of intersection. I prefer to call it a profile of intersection, because it is a profile. It's a profile that we're going to have to join a selection of dots, freehand them all together afterwards as we find this wrapped profile, solid and hidden and whatever it may look like down in plan and up in the end elevation here. So that's my first 2 points. I'm going to break up my elevation now, just like is shown there in the model. And I'm going to add some numbering at this point. So if I just make my way around, maybe from point 1 up top, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Well, those 12 divisions right there will give me a series of points. If I can find one in every view, well, which I've already done because it's on the extreme generator, it is right out here at 1. I've also found 7 over here. I've found 1 down in plan, and I have found 7 down in plan. So that's a start. Okay, it's just a start. That's all it is. What can I do next? Well, let's just look back at the model. We just turn this model again and just see what's happening with it. If we go the other way, that point is number 12. But if I can project from 12 in to hit the surface, and then I can take element down through that projection. Okay, so just like in the previous question where we were dealing with a pyramid, we could see the point on the square based hole that was cut out. We knew it was on the surface, we took an element through, and that got us 1 point of intersection. And if I can repeat that then 12 times, but it's not 12 anymore because I have the top and bottom, so 10 times. If I can repeat that process 10 times over, I can solve this question. So it's a lot of repetition of what we did in our last question as well, but we need to understand it. Now, what does that look like? Do I need to draw this green line in any view at all? Because as I look in, we see now that we have the green line, it just becomes a point view. So an element down through the point view of that green line brought down onto the ground. That will solve this question for us if we can do it 10 times over. We need to obviously make sure we're being really accurate here as well. So that is the plan. That's what we're going to be doing. We're going to be taking all of the divisions that we have, except for 1 and 7, because I've already finished them. We're going to be, in theory, we're going to be projecting them in to find their intersection point. But in reality, on paper, we're just simply going to be drawing the element in the elevation as it's given, and then we have a point on the element. We'll go down to the plan, we'll draw our element, and we'll project down to hit, and we'll go across into the end elevation, and again we get an element if we need it, which we won't actually in this case because we can just project between our views, and we'll get a point on the profile or the line of intersection. The good news this time is that we don't have to do everything in this view, because when I turn on my hidden detail, well, one profile is in front of the other because the object is perfectly straddling over the extreme generator there, so the hidden profile is just directly laying behind the solid profile. Down in plan, on the other hand, we're going to have a little bit more work to do in plan, because that's what it looks like. Wrapping around from point 1 up top, around to 2, 3, 4, 5, 6, 7 at the bottom, and 8, 9, 10, 11, 12, and back to 1 up top. That's our plan. Let's get drawing. Okay. This is going to get quite busy on paper now, so if you're drawing this along with me at home, keep your work as tidy as possible. I'm going to start off out here with number 2. I'm going to do it all in pencil because the fine liners are just a little bit too thick for this kind of work. That's down to number 2. Number 2 is on the ground. I'll just dot them. I'm not even going to label them now because I know I'll run out of space. And it's not going to look neat if I have too much in there. That's the element, and the point 2 lies on that element. And once I get a point, I'm going to just dot it with green right here. That's point number 2. And we just keep repeating the same thing, so I might just forward this portion of the video so that you're not watching me draw every single line. I'm gonna go ahead and draw all of the elements here on the right hand side, so going through 3, 4, and so on. Now there's a fair jumble of points up there in plan. What we're looking for first of all might be just the extreme left and right. So where the extreme left, which is point 10, and the extreme right, which is point 4. So the object going in until it hits point 4 and going in until it hits point 10. Now, not sure how anyone at home doing this would feel about it, but I think it wouldn't be too bad to realise then that from 10 it's heavy up as far as 1 and then back down to 4, so it's all solid profile up to 1 and down to 4, and then it's all hidden underneath. So let's go ahead and get that one done. So this, in my opinion, it's not it shouldn't be called a line of intersection now, it's a full profile of intersection. For hidden detailed freehand curves, I think it's good first of all to really lightly go around them to get your profile mapped out, and then come back and do your hidden dashes, because if you try to dash them at the start, they usually don't end up being very neat, or maybe mine won't be very neat anyway. But I think that dropping them in first of all really lightly will certainly help with getting something pretty neat. I'm going to get my compass now, and hopefully this worksheet is printed off fairly well and the curves match. Not very well, but I want to heavy in the portion of the curve that's visible and hide the portion that's underneath. I'm going to start adding a little bit of colour here to plan now. Now, nothing terribly fancy or tidy about that, but it does give a great impression of what we're looking at. From here, we should be anyway, hopefully, depending on how accurate you are, that of course 6 and 8, I mean it's symmetrical across the centre line, so 6 and 8 should be lining up along the same projection, 6 and 8. Then we'd have 5 and 9 lining up along the same projection, and you know, I'm surprised there, now they are actually working out quite well. 4 and 10. It's very easy with questions like this that your accuracy might go off just that little bit. 1. Now 3 and 12 there are, was that 2 and 12 are slightly off for me. I'm going to just make the best of it and just go between them there. They're quite close. And then finally 3 and 11, again slight, but we bring them together because they have to be symmetrical. If I have a point in 2 views, I can find it in the 3rd view. I don't need to draw all of the straight line elements. So I have 7 is already done, 6 and 8. Now if you are more comfortable and if you want to ensure that we don't make a mistake in the next view, well, label 6, 8. There's 6 and 8. Next we have 5 and 9. And now, just to change around my model, what are we going to be seeing here? We should be looking for that guy right there. I'm going to turn off my element line right now so that we can't see that for a while. Did I just project 5 and 9? I did, and I followed them, traced them up onto the XY and just labeled them quickly, 5 and 9. And then we have 4 and 10. The one at the front and back in this view. 4 and 10. We will then have, this is getting really close, 1's already taken, 2 and 12. 2, 12, and finally is 3 and 11. That now is getting very close, 3 and 11 in there. As I've said so many times in these videos, if you're more comfortable with just taking maybe 1 or 2 points at a time, please do so. You know, don't feel the need to take everything at the same time, because it can get really confusing, and in all fairness, it can be so easy to make a mistake. Projecting points across, I'm going to start with 4 and 10 now. All pairs are lining up here. I'd like to start here with 4 and 10 along the centre, and up from 4 and 10 right there. I'm not going to number because I think that it might get in the way this time. That's 4 and 10, and I also think that the profile will work itself out. I'm going to bring across 2, 3, should take that further, 3, 4 is done, 5 and 6. So 2 across, 2 up, 3 across, and 3 up, 1. I'll number them now, actually I can stay outside it now and I know they won't get in the way. 2, 3, that's 4. Where's 5? 5 across, 5 up, and 6 across to 6 up. As I said, the back points, so for example 11, which is behind 3, will be on the same point, and 12 is behind 2, but a solid line takes precedence over a hidden line. So once I join the dots, that is it, that's the drawing finished. And there we have our profile of intersection in the end elevation. A final little bit of colour to add. And there we have it. That is the complete profile of the end elevation and plan, including hidden detail dropped in there in plan. I think that again you get a false sense here when you have your colour used, that it's so obvious what the outline of the object is, but I'll just heavy in that extreme generator right there. That right there was maybe just about a 22 minute video for this particular question, including all the explanations that go with it. So when you draw this at home, and if you're comfortable with it, you'll comfortably get a drawing like this done in about 12 minutes or so. So realistically, it could even become it could even be posed as a Leaving Cert short question, section A, or it could be a part of a section B question. So using elements to solve the intersection of two solid objects, and in this case two nice objects, a cone and a cylinder. So as long as we can do what I did here on the model, and what I had on the model which really told the story itself was our straight line. That green line I talked about earlier, but I didn't really allude to again after that. Green line is any line on the cylindrical surface. We structured it about our 12 points. Now where is it? That one right there is on number 12. Just to bring a bit of understanding, that's number 12 right there. Where is it in plan? Well, that green line that's on my model is right there. So I've gone in, drawn my green line, and that green line goes until it hits. It goes until it hits this element right here. And that element, as drawn in elevation, is also drawn in plan. And that's how we structure this question. Repetition of that same theory over and over. In the end elevation, then, if we just turn this to the end elevation for a moment, the hardest to view, I suppose, in this case, well, the green line was here. And 2 and 12 line up, so there was the green line right there at the back of the object. And if we wanted to, we could have used the elements again over here and found every element which will grab every point again for us. But just an easier way is, if you have a point in plan and elevation, just project through your views. If you have it in 2, you can find it in 1. But there is our straight line elements method right there. And it's an elements method of finding the profile of intersection between two solid objects, in this case namely pyramids and cones being intersected by objects. This is the second in a series of videos that goes through all methods and then some Leaving Cert higher level questions on intersection of solids. Thanks very much for watching.